Hi, everybody. Welcome to Byte Ventures, where we deep dive into the marvels of technology. It has been quite some time that we discussed about the part one of scaling productivity on microservices. So let's dive deep in without any further ado. So in this second part of the case study, we'll discuss about how Lyft was scaling its productivity on the microservices. So if you remember the first part, we discussed about the problem statement, what were the challenges Lyft were facing, and how did it managed to create its own development environment, which is dev box, and then ran it on an EC2 instance, which is one box. So if you haven't watched it, I have linked the video in the description. I would highly recommend you to watch it to give a better idea of how things are, and it will make these things much more beautiful. Okay, so think about a development cycle if you're a developer or if you're a product manager or related to tech industry. So a developer, when given a changes, he tweaks his code, writes unit tests, and runs his code multiple times before giving out to review or before running into a bigger environment. So we'll term this two kind of development as inner dev loop and the outer dev loop. So what does inner dev loop mean? So inner dev loop is like kind of feature testing, running unit test and all stuff. And the second part is the outer dev loop where they need to seek for code reviews and run the whole thing on the code integration pipelines and all stuff. So if you think about this, inner dev loop is something which is used more often than the outer loop, because once you know that your feature is working, you will promote it to higher environments like QA or staging or pre-prod or stuff like that. So this has a very higher usage in comparison to outer dev loop. So if you talk about the 80-20 rule, we can say that this inner dev loop is probably used 80% of the time, while the outer dev loop is used 20% of the time. That's just an assumption, but you know what I mean. Okay, so when I talk about inner dev loop, what are the things that are being done? So when a developer at Lyft was using one box, like we discussed from the part one, they had to make changes to sync their code with the remote one box, because now that the dev box is running on an EC2 instance, they have to sync their code with the remote one box. Because the environment was fickle, it took a lot of startup time sometimes, and sometimes it was failing with a lot of build errors, and it needed a lot of rebuild uh, for the for the start of the inner develop for a developer. That was very painful because developer doesn't want to wait for certain things to get fixed, and they want to like, okay, I will use whatever I have available, and that is why they were resorting to the outer develop at each iteration. What do you think was the problem with this? The problem with this was it was leading to higher iterations because the outer dev loop is not meant for faster iterations and quick, rapid iterations. So it increased the development cycle. So the team at Lyft focused on fixing the inner dev loop in a much more better way. So what they did, let's discuss. Okay, so first, one box was running all of the service together, right? So one box was running all of the service instance in that one box, and that's how the name it is. They wanted to make things much faster, so they tried to isolate single service into an isolated environment. So they wanted to have a single service running in a single environment so that it'll be easier for them to debug issues and all stuff. Second thing is like isolating service is just one part of the thing. When you need to run an isolated service on its own, you need to make sure that the tests are running. So they wanted to isolate the test, and they started to put some efforts in isolating test for those isolated services. And third, they tried to run things natively instead of running things in Docker in a remote box. They wanted to run things natively, for which they can leverage the improved IDE support, and it will make the debugging much more faster. Here is one thing. So when people use containerization like Dockers and all stuff, though it makes life easier in much more cases, but it comes with a pain point that whenever complex issues like file mounting, networking issues comes, the debugging is much more harder than when things are running natively. That is one of the pain point that comes with it. So eventually what it looked like is like they tried to move the development from one box, the local development or the inner dev loop, from one box again to the local machine. Okay, think about local machine. What is the major pain point that occurs when someone tries to do a local setup? With each new joinee, you need to fix the environment for each developer now. That because previously each developer was using the same cloud instance, but now that each developer has an independent laptop, you have to fix the environment. So that was a challenge, and that's why the team came up with something to maintain this as well. So most of the services, or the most of the backend services in Lyft were running in Python and Go. So they wanted to make sure that at least the major services are captured and things are pretty simple for these things. And similarly, they wanted to make things simpler for Node, which was their front end layer as well, Node and React. So for Python, if you have worked in Python, you need to make sure that you have a virtual environment, you have all of these requirements installed, you have to install the correct Python version and all stuff. So they wanted to build a wrapper so that not everyone has to go through the same steps again and again. So they built a virtual environment, or VENV in short, for each service, which was responsible for maintaining the correct version, installing all the libraries that were defined in the requirements.txt, and creating a new VENV or sort. They use something called as activator. Uh, it is from Yelp, which is used to activate, because once you create the VNB, you need to activate it, right? To make sure that you're using it in the right way. So activator from this Yelp make sure that whenever you enter a service directory, it activates it, and whenever you go out of the directory, it deactivates it. So they use this activator to make things simpler. And also they made sure that this VNB is immutable. That means whenever there is a change in the requirements.txt, it would trigger a whole new build rather than existing or modifying the existing one. And the second thing was like the old version was cached in case the user has to roll back to the previous version. Second, for Go, the things are pretty simple. It didn't require a lot of things. So they just had to set up the download URL, and the Go runtime toolchain was pretty smooth and efficient to handle all of the things on their own. Coming to Node, Node had also the version problems. So each Node service required a right version of NVM and all stuff. So they wrote a custom wrapper over Node env to make sure that people don't face the problems of versioning and all stuff. And that made their life much more simpler. So there is another thing. So you think about this. So once we have Python, Go, and Node services, each service as a microservice would require a database kind of thing, right? You instantiate the database, you load the files and all stuff. And also there are certain Linux services which require containerization for that as well. And that were kept in Docker like before. So they're like, now, if you think about it, now there are a bunch of steps each developer need to run to make sure that service is up and running so that they can use it to make their code changes and all stuff. That is when they were thinking that, okay, let's talk about Tilt. So Tilt is something they use to automate this whole process of making their local environment ready, like run this bunch of steps, install the database, run the script to fill the records in the database, make sure that this port is free. If not, kill the services in that port, up this service, connect with the database, and make sure that everything is running. So it's like a bunch of step-by-step steps. And they found to use Tilt because Tilt was kind of guaranteeing those kind of stepwise execution very, very efficiently. Though Tilt had a very different purpose, and you can check the internet of what it does. It's very interesting in terms of what it does to Kubernetes development environment and all stuff. But they have leveraged Tilt to make sure that the local development environment is seamless. So after integration with Tilt, each service had a Tilt file specifying the number of execution steps, and it was like pretty common. Connect to Dynamo, restart the service and all stuff. And the developer had just to run this tilt up command. So whenever this tilt up command is fired, the tilt up went to parse the tilt file, and then it starts the execution plan, and everything is up and running. Once service is up, they had huge advantage of hot reloading as well, because now that whenever there is some change in the IDE, the service would go and restart by itself. Okay, and now the major part comes in the picture. Once they have broken the services into smaller chunks, things doesn't work that way, right? Because they had the microservices architecture, they need to have some way to connect to all services. So if I'm working on service A and I need to make a call to service B or C, it's not possible for me to run service B and C in my local. Because if that would be the case, then I would have to spin like probably 1,000 or all the services that I had to make sure that my service A is running smoothly. So there are two ways to it if you think about it. The first is returning mock response. So whenever you call a service, you get a mock response irrespective of the state of the service, right? Which is like a static response. And the second is a dynamic response where you actually send the request to a server rather, where the actual service is running, and you get back the response. So Lyft handled this situation pretty efficiently by managing this two kind of end scenarios or end situations in a very effective manner. Okay, let's talk about proxy-app. So a couple of years back, because Lyft was heavily dependent on the mobile client, they wanted the mobile developers to not depend on the backend services API, stuff like that. So they built this proxy app to make sure that the life of the front end or the mobile client developers is easy, and they don't depend on the backend team for the feature request so that they can test their app. So what this proxy app did is like it had an architecture like this. So this every mobile app simulator connected to a proxy server connected to proxy app, which internally connected to API. So instead of directly connecting to the API, they provided a middle layer so that if the backend API is not released here, they could use this mock response object to modify or override the response that is coming back from the API and make sure that whenever the backend feature goes live, the mobile UI doesn't break or it functions as they want it to perform, right? So basically it is used to build things on their own. The major advantage of this proxy app was the something called as Lyft's interface design language or IDL. So it helped them make sure that the auto completion is already there, which is provided by a TypeScript Monaco editor. So this editor kind of took care of situations where they need to import certain types, made sure that this is working as expected and all stuff. So they tried and to think that, okay, this is the exact situation that everyone now is facing. So why don't we leverage this app? That's what they did. So this is the local developer environment box, and this is the local service that was running. This was the proxy app. The my service would call the proxy app to call service B. So let's say this is service A I was talking about, and this is the service B, which is not present in my system, but would required for the execution of service A. So instead of calling service B or staging directly, I would call the proxy app, and then this proxy app would call the staging environment, and based on the mock response that was configured here and based on the response from the staging environment, I would decide that, okay, this is what I want, and I want to test whether if this is the latest response that comes from the service B, how would my app perform in that case? So each service was running locally, so the data store you see is local data store that each service or each developer laptop was running. Okay, as we talked about this TypeScript code editor, this TypeScript code editor allowed them to fire request to their own services. So that made their life much more simpler, right? And that was very seamless. So let's see what are the results. So now when they had this one box, making a change or building things when things broke took hours. And now that everyone was running things in local, the chances of failure are much more lesser, and spawning up new services and sending out test requests took few minutes. It's like a couple of minutes, let's say 2-3 minutes to 1 hour. It's like 10 to 20x time reduction in spawning up the instance. So now that everyone is aware of the local debugging, things were much more simpler when the actual bugs came in, because now that people know that, okay, this is the path they would follow, they would mock certain things when overridden and all stuff. Things made much more easier for the lives of developer. Now, everyone didn't need a beefy AWS instance, and for that reason, AWS cost went down massively. And the developer productivity was, which was the primary point for which Lyft was doing all of this, took a huge success after this. Okay, let's talk about what the future work the Lyft is planning in that case. So, as we talked about Lyft talking in native development, Apple had produced its M1 and M2 silicon chips, and they're trying to experiment that whether the service that are running is not interrupted by the M1 and M2 things. So now you remember we had a TypeScript Monaco editor, right? So which is used to create requests, fire them to the local service running on the system. What if you want that service to fly across multiple staging services and the data getting massaged before reaching my service? So that feature is not yet there. Lyft is working on that feature to make sure that you can have different kind of massaging for different kind of services. Third, sending request is not as easy or as user friendly as like a Postman kind of thing, because they have protobuf, different kind of JSON, they have different kind of formats. They couldn't use Postman directly. So they want to improve the UI to send the request to the local services, which would make the life much more simpler. And fourth and foremost, with GitHub coming up with GitHub code spaces and all stuff, they want to explore this kind of situations, whether they support the productivity of their developers as well. All right, that's all I had for today. Let me know if you have any questions or feedbacks in the comment section. I will attach all the reference documents in the description of the video. And yeah, have a nice day ahead, guys. Thank you, and see you in the next one.